Hey, algebra friends, here we are looking at section 8.4. We're going to talk about polynomials. So what is a polynomial? So we talked about monomials, right? We know that monomials are these little individualized terms that are by themselves, right? So you might have n squared plus x squared y minus 3x. And each of these are monomials. But together, when there's more than one, we get a polynomial. So a polynomial is a string of monomials, more than one obviously, that are being added or subtracted. So that's a monomial. A binomial, the prefix bi meaning two, indicates that we have two monomials being added or subtracted together. So here's a binomial. Here's another binomial, 2x minus 7. Here's a binomial, a squared minus b squared. There are two terms that are left once we've simplified as much as possible that cannot be simplified any further, and that gives us two distinct monomials that are being either added or subtracted together. And I think already you have figured out what a trinomial is. So this trinomial means that we have three monomials being added together. So x squared plus 2x minus 1 is a trinomial. Or, I don't know, let's say, you know what I'm saying? 2x to the, not the m power, that's crazy. 2x to the third power minus 3x plus 1. This is a trinomial because it's a polynomial with three terms. Is that all right? So now we can talk about the degree of a monomial and the degree of a polynomial. So let's look at a couple of examples first. So 3 is a monomial. 4x to the third power is a monomial. Y squared times x to the fourth power is also a monomial. And let's think of another one. 2x is a monomial. So if I wanted to talk about the degree of a monomial, right, what I'd be talking about is the greatest number of variables that are there, like the number of variables that are there. I know that sounds a little weird, but there's no variables here, so this has a degree of 0. So this has a degree of 0. Here's a variable, it's x. It's one variable, but it's there 3 times, so this is a third degree monomial. This guy has two variables and they appear twice and then 4 times here. 2 plus 4 is 6. This is a 6th degree monomial. And here we have 1x is to the first power. This is a first degree monomial. All right? So that's how we think about degrees. That's what degrees refer to. Degrees are a description of, in a sense, the number of variables that you have there. And let me see a good way to get rid of this so I can, well, let me just do it down here. All right. So the next thing we're going to talk about is the degree of a polynomial. And the degree of the polynomial is really just the degree of its highest monomial. Say what? So I know you're like that, right? So if I had 2x to the fourth power plus 3x squared minus 2x plus like 9, look at the monomials that make up this polynomial. We got this one, that one, this one, this one. This one is the monomial of the highest degree. This is a fourth degree monomial, and therefore this polynomial is considered a fourth degree polynomial. Is that cool? I'm hoping it is. All right, so fourth degree polynomial, and with that, let's move on to some other cool things. So here we are with example 1, and we're going to identify polynomials. So is this a polynomial, yes or no? I'm going to go with a yes here. And monomial, binomial, or trinomial, it is a binomial. You guys see where we're going with this? I'm just going to put B because that's what I'm going to do. So it's B. It's a binomial. All right. And over here, this looks like a binomial, but remember the thing? We need to make sure that we have no negative exponents. So we're going to go no here. Since this has a negative exponent, this is not a monomial, though this is a monomial. This isn't, and adding these guys together makes it something else. So it's not a polynomial at all. And is it a monomial or a binomial? I'm going to put no, it's none of those. This right here happens to be a I'm going to go no with it's a polynomial. It is a monomial because it's one term and it's at -8. I think there might be some discrepancy with your textbook, but I think go with me, follow me. Poly means many, it has to be more than one. So it's a monomial, it's alone. I'm just going to leave it there as a monomial there. And so no, it's not a polynomial. Over here, we can do some simplification. You see, we've got 4a squared plus 6a, because there's like a 1 there, plus 9. And you see, when I simplify it as best as possible, I still have many terms being added together. All the exponents are positive, unlike here. So yes, I've got myself a polynomial. And it is specifically a trinomial, because there's 3 terms. Trinomial. And so could you tell me what the degree of this trinomial is? Remember, to find the degree, we search for the monomial with the greatest degree, and that's this one, and the degree is 2. So this is a trinomial of degree 2. Here in example 2, we're going to write a polynomial given this particular expression. So we're going to write a polynomial to represent the area of the shaded region. So anytime I have these shaded region problems, I need to wrap my head around what's going on. So I see that the shaded region is going to be this rectangle minus this circle. And so I know when I see something like that, I've got to recall the area of a rectangle being base times height, or some people say length times width. That's all good. And the area of a circle, let me put a little rectangle down here so you know what I'm talking about. Area of a circle being pi times r squared, right? And we know that means pi times r. That's not a pi, is it? You're looking at me like, what are you doing? Pi times r times r. All right, pi times r times r. So that's what we need to do in order to find the area of the circle. And so none of this is telling me the area of the shaded region, but it looks like if I found the area of the rectangle and then subtracted out that middle part, which is a circle, I'd have the area of the shaded region, right? The shaded region looks kind of like this. So this, I'm just putting together a plan, like a mental plan of what's going on. So I recalled all the information I had. I'm putting together a mental plan of what's going to get me there. And now I need to do the thing. I need to get there. So the base of the rectangle, or the width of the rectangle, is b. So that's convenient. And then the height of the rectangle seems a little tricky, but if this is the radius from center to edge, then this also over here would be the radius from center to edge. And if I've got 2 radii, what I now have is the diameter, but I'm not going to use a new variable. I'm going to use the variable that they gave me, which is r. So r here, r there, that means the height of this, the length of this, or the height of the rectangle will be 2r. So I got what I need for that. 2r and b are the dimensions of the rectangle. Therefore, base times height will be b, which is the base, times 2r, which is the height, or the length times the width. The next thing we're going to do is subtract the area of the circle, which we know to be pi r squared. So it's going to be pi times r squared. We don't have a value for that. That's our expression now, and that's going to be equal to the area of the shaded region. So write a polynomial expression. We did it. And so I'm going to write this a little bit neater just because I want to. I've got 2br, just change the order here, minus pi r squared. And this is the expression. It's a polynomial because I can't join like terms together, because this is r and this is r squared and they're not in common. So I'm good to go. That's it. Here in example 3, we're going to do the thing you already know how to do from our discussion about vocabulary. And the fact is, we need to find the polynomial, the number of terms, the degree of each term, and the degree of the polynomial. So this polynomial, they're calling this a polynomial. I'm going with no. I'm not buying it. I do not believe we should call a monomial a polynomial. That's just my biased opinion. And when I looked it up in the dictionary, it said many terms. So I'm not buying it. But anyway, I get that your textbook has a different definition, and we're going to deal with that and keep it moving. So the number of terms, we've got 1. The degree of each term, well, the degree of this term is not 2, but 3, because there's 3 variables here, m, n, and then another n, all being multiplied together. So we're going to say The degree of the term is just 3, and the degree of the polynomial is 3, or degree of the whole thing is 3. I'm not going with this polynomial business. All right, let's look at this next guy. So this next one has 1, 2, 3 terms. Notice even though this has x squared and this has x squared, this one has a y squared, which means they are not like terms. So I have to count each of these, 1, 2, 3, as separate terms. The degree of the first term is 4, because there's 4 x, x, y, y variables here. This one has 2 variables, x, x. That's 2 variables. And this one only has no variables, so that's a degree 0. Since the highest degree, the highest monomial degree of this polynomial is 4, the degree of the entire polynomial is considered to be 4. The next thing we want to talk about is this guy over here. Everything's as simplified as possible. I've got 4 distinct terms. I've got 4 terms here. And each of those terms has a degree. The degree of this term is 1. The degree of this term is 2. This guy over here is 3. And this last one is 0. Considering that 3 is the largest degree of all of the monomials, lets me know that 3 is the degree of this polynomial. In example 4, our textbook authors have us considering rearranging a polynomial, and we've talked about this before in terms of moving things around. I want you to know that each term takes on as its sign the sign or the operation sign that is before it. So basically what I'm saying is, as long as you move each color around, each of the terms around with the sign in front of it, you're doing legal stuff, right? It's totally legit. It's totally the same thing. What they asked us to do is to arrange it in ascending order. To ascend is to go up. Ascending order powers of x. So we would start off with negative 11 because that's the smallest one, and we would ascend, we'd go up 7x squared plus 2x to the 4th power would be the way I'd write that. Here we're going to do the same thing again. We're going to do it in ascending order. So we would start with the smallest, which is y squared. And then we're going to, oh, wait a minute, so that the powers of x are in ascending order. Sorry. No, I think that's cool. I think they just said so the power of x. Okay, I'm still in the game. All right, so I'm going to deal with the y because there's no power of x there. And I'm going to deal with this guy because the power of x here is 1, 2xy to the 3rd power. And then I'm going to come over here to the 2nd power, minus 3x squared y, right? No x, 1x, 2 x's. And now we need the 3 x's. And that's going to be plus 5x cubed. Notice that this negative 3xy is still here. This positive 5x is still there. Positive y squared, and this positive 2xy cubed is still in the game. Example 5 shows us the way we typically write our x powers in descending order. We start with the biggest and we go down, and that's what we're going to do today. So we'll start off with this guy. I have to call it a negative 2x cubed, right? And then that's a positive 6x squared minus 8x plus 5. So notice that the x values go down in degree, and then we'll have this over here, or in power. We'll start over here with the x to the 5th power, so that's 4ax to the 5th. Look next for our next highest x value, which is going to be this guy over here, plus 3a cubed x to the 2nd. Finally, we're going to come over to this last term that has an x in it, and then finally we'll bring this last one here that does not have an x term in all in it. So we know when there's no x term there, technically it's like x to the 0 power, because anything to the 0 power is 1. You get me? Kind of, sort of. All right. Guys, that is it for this lesson. That's all we're talking about today, is just recognizing polynomials, what they are, knowing their definition, checking out their degree, and being able to move them around. Not too bad. Hopefully the assignment associated with it feels okay, and I look forward to talking to you guys soon. Take it easy. Bye-bye.